Now my friends, here let us see how to take use of factor theorem in factorizing different polynomials. A lengthy polynomials having power 2, 3 and so on, and let us see how to take the use of factor theorem. For that, let us take one question so that we can systematically study about how to take use of factor theorem in factorizing a different types of polynomials. Let we have this type of polynomial and we want to check out whether the x plus 2 is factor of this given polynomial or is not factor or not factor. This we want to check it out. Now, you know what we do? You know the 0 of x plus 2. What is 0 of x plus 2? We have 0 of x plus 2 is x plus 2. What is 0 of x plus 2? It is minus 2. And by taking x is equal to minus 2, let us put the value of x in place of the x in the polynomial and find out the value of the polynomial. You know, our polynomial is px is equal to, the given polynomial is x cube plus 2x square plus 3x plus 6 is our given polynomial, and we want to find the value of polynomial for at x is equal to minus 2, which is the 0 value of x plus 2. That will give minus 2 cube plus 2 in bracket minus 2 square plus 3 in bracket minus 2 plus 6. Okay. Now here you will get minus 2 cube. The value of minus 2 cube will be minus 8. And here 2 square will be 4. 4 2s are 8. Here we will get plus 8. Now what we will get over here? Plus minus 3 2s are 6. And again 6. Do you know what over here? This plus 8 minus 8 cancel. Plus 6 minus 6 cancel. What we got? The value we got, that is equal to 0. What you will get the conclusion then? Therefore, you know, here you got that p minus 2 means value of the polynomial. You got 0. Therefore, you can say that x plus 2 is a factor. X plus 2 is factor of your given polynomial px. This is how we can decide whether a given linear polynomial is a factor of given polynomial or not. Okay, thus you are able to decide by using the factor theorem that given linear polynomial is a factor of the given polynomial or not. Let's take one more example. Here the question is factorize using factor theorem. Actually, this type of polynomial, quadratic polynomial, the method is easy by splitting the middle term. But here, as we are going to study find the factors by using factor theorem particularly, then here we will not consider about by splitting the middle term. Now for our convenience, I will write this polynomial as, suppose 2 in bracket. If I will take 2 common, then I can write the polynomial as x square plus 5 by 2x plus 3 by 2. Okay, like this I can write. So here now, and if I will say to you that, suppose here A and B, if I will say that A and B are the zeros of factors of this polynomial, what I am telling, if A and B are zeros of what? Of zeros of factors of this polynomial. Why I am taking factors? Because the factors are in the form of a linear polynomial. Factors of the polynomial in x. Then I will see this polynomial. Now here I will take what you can say about a constant term. Here your constant term is, is 3 by 2. Now if A and B are zeros of this polynomial, then I can write it, the polynomial, as 2. How? 2 in bracket x minus a and x minus b. I can write the given polynomial in this form. Okay. Now I want to find out all possible values of a and b. Okay. Now let us find out what could be the possible values of a and b, so that PA will be equal to 0. What possible values of a and b? Possible values. Whose possible values of a and b, so that the value of the polynomial will be equal to 0. Such type of possible values of a and b we will search. What you can say about the possible values that could be? For that you have to see about a constant term. Your constant term is 3 by 2. Okay, so the possible factors I can write it as, if I will consider the possible factor, suppose a, the value of a as plus or minus 1, at that time the value of b will be plus or minus 3 by 2, because if I will multiply these two values, I could get 3 by 2, product 3 by 2. How? Plus 1 and plus 3 by 2, 1 into 3, 3, 2 and 0. Product of these two will be 3 by 2. If I will use minus values, minus 1 into minus 3 by 2, again I will get 1 into 3, 3, 3 by 2, and so on. Again, what type of possible values I can take? If I will take the value of a as, say, plus or minus 1 by 2. Okay, the value of a as plus or minus 1 by 2. Then I have to take the value of b as, what can be the value of b? It will be plus or minus 3. So these 6 values are there. Okay, 1, 2, 3, 4, 5, 6, 7, 8 values. These 8 values are there that can be possible that they are having the product 3 by 2. Now let us search one by one which value can satisfy the value equation, so that its value of polynomial will be equal to 0. For that, let us say about 1. First of all, we'll take the value here. If you clearly observe towards this equation, here one thing you can guess and you can minimize your work. How? If you see towards the polynomial, then all the terms included in the polynomial are positive. So if you use positive values from these possible values of A and B, you will get positive answer only. For example, if you use +1 here in this polynomial, then here all the terms are positive, so you will get positive answer only, and it will not be equal to 0. So positive values in this case are not suitable for finding the factor. That's why now what is left? Only negative values are left. So here we will try for -1, -3 by 2, -1 by 2, and -3. And for these 1, 2, 3, 4 values, let's check out the what can be the factor or not. For in number 1, we will use in number 1 the value -1, and we'll check out. Here for p -1, the value of polynomial. Which polynomial here we will take? 2 we have already taken, so we will use the polynomial x square plus 5 by 2 x plus 3 by 2. In this we can put the value and you can find your answer. What you will get? X is equal to -1, so here I will get -1 square plus 5 by 2 into -1 plus 3 by 2. Okay, like this I will get over here. That will be equal to -1 square will be 1, and here plus minus minus, here I will get 5 by 2. That is plus again 3 by 2. If you will add this plus 3 by 2 and 1, you will get 2 1 2 plus 3, 5 by 2. And here this is -5 by 2. Answer is equal to 0. As the value of polynomial you got 0, you can say that which is factor, x plus 1 is a factor. X plus 1 is factor. Okay, now let us check out for, here you got it is factor. Now let us check out for the value p is equal to -3 by 2. For that, in second example, we will take the value of -3 by 2. Let us check out p -3 by 2. That will give you actually that is equal to -3 by 2 square. Okay, -3 by 2 square plus 5 by 2 into x. X means -3 by 2 plus 3 by 2. Okay, what you will get over here? Here it will be 3 3 are 9, 9 by 4. The square of -3 by 2 is 9 by 4, plus here the product of these two, that is equal to plus minus minus 5 3 are 15 by 4, and here plus 3 by 2. What you get? That is equal to 15 minus 9, that is equal to 6 upon 4. That is plus 3 by 2. And here here 2 2 are 4, 2 3 are 6. Minus 3 by 2 and plus 3 by 2. What you can get over here? Here you will get again 0. Therefore, you can say that here what is factor? X plus 3 by 2 is a factor because you got the value 0. This is what factor theorem tells you. Therefore, x plus 3 by 2 is a factor. Okay, like this you can check it out. So here you got this is also a factor of the given polynomial. Now let us see for the next value. Here we took minus 3 by 2. Let us check out for minus. Here we'll take minus 1 by 2. Now I will use the value in third as minus 1 by 2. Here I will write p minus 1 by 2. It will give you that is equal to minus 1 by 2 square plus 5 by 2 into x. X is minus 1 by 2. That plus 3 by 2. Calculate what you get. Here 1 by 2 minus 1 by 2 square will be 1 upon 4. And then here plus minus minus, that is equal to 5 by 4 plus 3 by 2. Then overall calculation is that is equal to here minus 5 and plus 1 will give minus 4 upon 4. That is again what is left? 3 by 2. Okay, so here what is left? Minus 1 plus 3 by 2. The total answer will be equal to 2 1 are 2, minus 2 plus 3, 1 by 2, and is not equal to 0. Therefore, x plus 1 by 2 is not factor. Okay, here, and let's take about minus 3. Check out for minus 3. If you take the value minus 3, then what you can get here? Let's use in 4 that for minus 3. Put minus 3. Therefore, p minus 3 will be equal to minus 3 square plus 5 by 2 into minus 3. Okay, plus 3 by 2. When you will put it in the polynomial, so here you will get 3 square minus 3 square 9. Here plus minus minus 5 to the 15 upon 2, and here plus 3 by 2. So here you will get it as what? 9 to the 18. 18 plus 3, 21. 21 upon 2 minus 15 upon 2. You can get it as 21 minus 15, 6 by 2 is equal to 3 and is not equal to 0. Therefore, you can say that what you can say about this here, that x plus 3 is also not the factor. Is not factor. Then what are factors? Here from this 2 are not factors and 2 are factors. So overall factors here you got that this is not factor, and here you got that this is not factor, and above 2 are factors. Therefore, overall factors of the given polynomial are number 1, x plus 1 and x plus 3 by 2 are factors of the given polynomial. Thus, using the value method or a factor theorem, you can check out whether a given linear polynomial is a factor of a given lengthy polynomial or not. Okay, now here we will study the next example about whether the given polynomial is factor or not. Okay, this type of polynomial we have, so that we will here try to find out the factors of this. Do you know? Here I will write let a and b. Let a and b be zeros of what? Let a and b be zeros of factors of polynomial. Factors of polynomial py. And if a and b are zeros of the factors of polynomial in py, then how you can write the given polynomial? Then you can write the given polynomial as py is equal to what? Y minus a and y minus b multiplied by y minus b will be the factors of the given polynomial. Now what you can say about the constant term? Now here in this case your constant term is, we have a constant term. What is our constant term? Here you know it is 6. So we have a constant term, that is AB. Okay, and it's 6. So what can be the possible factors of 6? If you think of possible factors of 6, then you know the possible factors of 6 can be 1, 2 and 3 can be the possible factors of 6. But here we use plus and minus values. So I will write one possibility is plus and minus 1, another possibility is plus and minus 2, and the next possibility is plus and minus 3. But here, like last example, I have to take positive as well as negative values, because here one of the, in polynomial, if you observe towards polynomial, then one of the sign is negative. So we can't say about whether plus value will show or minus value it will show. For that, let us check out for each value. So first of all, here total, here 2 plus 2 plus 2, 6 values are there. So first of all, we will check out for number 1, that is for plus 1. For plus 1, I will check out the value of the polynomial. So I will use P1 and I will check it. Our polynomial, you know, it is y square minus 5y plus 6. So here 1 square minus 5 multiplied by 1 plus 6 will give us 1 square is 1 minus 5 plus 6. Overall answer will be 6 plus 1, 7 minus 5, it is 2, and this 2 is not equal to 0. So what can you say? Therefore Therefore you can say that what y minus 1 is not factor because value is not equal to 0. Now let us check for the second value. What is the possible second value? In second we will use say minus 1, and let's check out for p minus 1. So here p minus 1 is equal to minus 1 square minus 5 into minus 1 plus 6, and after calculation here will be minus 1 square will be 1, here minus plus 5 1 are 5 plus 6. Okay, here minus 1 square 1, minus plus 5 1 are 5, 6. The total answer is 6 plus 1 7 plus 5 12, and is not equal to 0. Therefore you can say that what here? Not x. Here you can say that y plus 1 is also not factor. Now let us check out for plus 2. What you can say for plus 2? Here if you use the in third, let us check out for plus 2. If you take p2, then you have here you get 2 square minus 5 into 2 plus 6. Then calculation tells that 2 square is 4 minus 5 to 10 plus 6. Here you get 6 plus 4 10, and 10 minus 10 0. That's what is your conclusion. Therefore you can say that y minus 2 is a factor. Y minus 2 is factor of the given polynomial. Okay, because value we got 0. Let's check out for another, for minus 2. If you take the minus 2 now, then for p minus 2 we have, you see, that is equal to minus 2 square. Minus 2 square minus 5 into minus 2 plus 6. What will be the answer? That will give you 2 square minus 2 square 4 plus minus it will be plus 5 to 10 and plus 6. The answer is 6 plus 4 10, 10 plus 10 20, and is not equal to 0. And is not equal to 0. Therefore you can say that y plus 2 is not factor. Is not factor. Now what you can say about, you have seen about the plus and minus 2, plus 1 and minus 1, plus 2 and minus 2. Now let us check out for the plus 3 and minus 3. What you can say about the plus 3 and minus 3? First of all, let's take the value for plus 3. Check out for plus 3 in fifth. Let's take the value plus 3. So P3 will give you, that is equal to 3 square minus 5 into 3 plus 6 will give you 3 square will be 9 minus 5 3 are 15 plus 6. Here you get that is equal to 9 plus 6, 15, 15 minus 15, 0. Therefore, what is your conclusion? Therefore, here you have used plus 3. Therefore, you can say here, you can say that y minus 3 is a factor. Is a factor. And let's check out for the last value. So here it is factor, and here it is not factor, here it is not factor, here it is factor, here it is factor. Okay, and what you can say about here it is y plus 2 is a factor. Okay, here you got 0, it is a factor. Here you haven't got the 0, so it is not factor. Now let us check for 6 whether it is factor or not. Now let's know about minus 3. P minus 3 if you use, then that will give you minus 3 square. Minus 3 square minus 5 into minus 3 plus 6. So here you will get it as minus 3 square will be 9. Minus minus plus 5 3 are 15 and plus 6. All the values are in plus. 9 plus 6 15 plus 15 30 and is not equal to 0. Therefore, what you can say, the y plus 3 is not factor. Is not factor. Is not factor. Okay. Now, what you can say once more, you turn towards all these 6 possibilities. Here, y minus 1 is not factor. Y plus 1 is not factor. Here you got 0. So y minus 2 is a factor. So one of the factor is your y minus 2 is a factor. Now after that, if you see about minus 2 here, then here also you haven't got 0. Therefore here y plus 2 is not the factor of the polynomial, but here you got 0. Therefore another factor is y minus 3. And in case of this minus 3 value, here the value of polynomial is not equal to 0, so y plus 3 is not factor. So overall factors of the polynomial in y are y minus 2 and y minus 3. Okay, like this, by using factor theorem, you can find the factors of the given polynomial by using value method. Okay.